have a square waveform here. Is the root mean square current equals to the peak currents divided by square roots of 2? Of course not, huh? Because that formula applies only for sinusoidal waveform. So for a square waveform, we got to work out the RMS value from first principle. So to get the root mean square value, remember, root mean square, huh? So we got to square and then find the mean and then root it. So let's start with the first step, which is to square the waveform. So this waveform is I0, then negative I0, then I0, then negative I0. So during this part here, of course, after I square it, it becomes I0 square. This is negative I0, I square it, it also becomes I0 square. So the square of the current is a horizontal line. Okay, so we have done the square. Now let's do the average. What is the average of this waveform? I0 square. The average of this waveform is I0 square. Don't make the funny mistake of thinking that the average of this waveform is I0 square divided by 2, huh? The value of the square of the current is constant, it's always this value. So of course the average of this constant value is also this value. It's like this number is 3.5, 3.5, 3.5, 3.5, 3.5, 3.5 all the time. So what is the average value of these numbers? 3.5. So we have done the average. Actually, even though it looks the same, but yes, we have already found the average of the current square is I0 square. So the last step is to root it. So when we take the square root of I0 square, we get I0. The very smart students will say, of course the RMS value of this square waveform is I0, because this waveform will dissipate the same power as a DC current of I0. Get that?